Hello, I want to give you an introduction to one very remarkable digital multimeters from the mid-80s, the Siemens B1023. It is from an era when most of the multimeters were basically clones of a Fluke innovations of the mid-70s. When Fluke built the very first handheld digital multimeter, they designed a chipset with Interseal. And Interseal itself started selling the chip with minor modifications to the open market. And a lot of vendors started building digital multimeters based on that chip. So that is still done by Chinese people. These cheap 20,000 count, 2,000 count multimeters from China, many times they just contain the same chip like a mid-70s Fluke, which is kind of incredible, but obviously not the build quality, not the input protection, nothing else beside that. But in the mid of the 80s, vendors started to do their own innovations and to create devices that are actually competitive. One of those devices was created by the company of NORMA in Vienna, Austria. Siemens had it built by them, and it was actually developed by them. They were a very reputable company, known for very good analog measurement equipment, and they even built some of those multimeters with Interseal chips for Siemens before. And they had connections to the company of AMS, that's a semiconductor company with fab in Graz in Austria. And in designing these line of multimeters, as far as I could research, they actually had them do the ASIC inside. So the ASIC that is driving the whole thing, the ADC chip, with microcontroller features, that is a chip that was produced in Austria as well. Where they manufactured it later on in mass numbers, I don't know, obviously, but it's pretty much incredible when these days you're limited to made in China for like 99% of the electronic products out there. What sets this apart from other meters of the time? First, 20,700 counts at a very, very high accuracy. Let me show you the manual for a moment. See, this is the user manual. It's including a schematic of the device. You can see here custom IC, all kinds of input protection. Literally they don't do it like this any longer. Let's switch to the English manual. You already see it has a wide variety of features. The manual goes further into detail than you would be used today. And the accuracy specification is unusual and remarkable for the time. 0.04% plus 2 digits at a little bit more than 20,000 counts. Auto ranging. It includes true RMS. It includes resistance measurement, diode measurement with quite a high voltage for the time, and even type K thermocouple measurement. You can do frequency counting and current ranges in 10 amp and 2 amp ranges. But all of that is not yet enough. You can see it looks like basically a pocket calculator. You might ask yourself, why is that? The device is a MAF multimeter. A bit different from what you would think of it today, but it allows you to not only hold a value on the screen. We all know this. pretty handy feature unless you need your hands to do stuff. That's why auto hold exists today, but at the time it was a pretty handy feature. You can do decibel measurements. You can switch between auto and manual ranging, and you can do the manual ranging not like cycling through the ranges. You can say up and down, which is pretty nice when you have to swap between two ranges and you just go up and down as you wish and not have to cycle like to 25 million different ranges before you have the range you want. It does relative. It does extreme values, which is basically min and max. It allows you to measure using limits. For example, you want to find a certain resistor. You have like, you know, a couple of these carbon resistors. They are not very accurate, but you want to select them down to a set of good values. You set the limit, you set an upper boundary, a lower boundary, and then the device will beep if you have a measurement inside the value, and you can switch it to beep if the measured value is outside of that range. It works with basically all kind of measurements you have. Functions like clear and the numerical reply to other functions. You can set the beeper on or off. Blank allows you to switch it to 2000 counts, which is pretty nice if you're working with the 12 volt range of a car. You just remove the last digit because it doesn't matter in most cases anyways, and it doesn't annoy you, and you don't start fiddling with 0.0001 volts of accuracy while dealing with areas where it is not needed at all. And it has something very nice. As you can see, it has a bar graph. Let me touch the tips for a moment. You see here a very fast bar graph, 25 updates per second. You might say not impressive, but in the mid-80s I would say it's rather impressive. And you can expand it. That means when I press it, it's centered, and now it will go to positive and negative relative to where I set it. A little bit like the rel feature, but with the bar graph, and it's zoomed in. So if you want to see minor changes up or down, that is very, very handy. Like charge, discharge, values going up, values going down, and you want to monitor this. This is absolutely unbelievable. Another cool thing is, using the time function, you can change the update rate. This is cool if you want to kind of monitor something over time, and you're not interested in the voltage going up and down all the time. You just want to have some definitive points where you look at it, like with the temperature, and you want to have a regular interval. You set like 60 seconds because you want to know the temperature from every minute. If you set it, it will beep every minute and show you the measurement of the time. So you have automatically like a good time scale. You can also use it to just reduce the rate that data is shown. So let me show you a little bit what it can do. For that I have prepared a set of LEDs, one cheap voltage reference based on the 8584JH that so far has proven to be not crappy, with a couple of precision resistors that have proven to be not too crappy as well. This resistor cascade, I just use it to get 1 mega ohm in comparison. I have a diode here and a high power LED, one destroyed old demo board, and one photoresistor to demonstrate the speed of auto ranging in ohms range, which is, by the way, a very good way if you want to know how quick auto ranging in ohms is. Just use the photoresistor. It's changing its value so fast that you can see if the device is actually good or just toying you. So let's start. I will start by giving you a short overview by the voltage reference. I forgot to charge it up beforehand, but it doesn't really matter. I'm in volts DC, and I will start at 10 volts. And you can see it quickly finds the range, and the coolest thing is the bar graph is always like faster than the display, even in ranging situations. This reading is actually quite accurate. My temperature currently is about 25 degrees. This measurement was done by the vendor. I don't know if it can be trusted or not, but I have confirmed that it's about right. Enough to make sure that my devices are not entire crap that I use at home for fiddling and toying with multimeters. So, oopsie daisy. Here's the 7.5. Hitting it quite well. Five volts. Perfect. Fine. No troubles with that. 2.5 volts. Everything wonderful. Basically, when I measure it with my BM789, I get about the same values from this board. So it looks like that a device that was calibrated based on some stickers I found on it in the early 90s or something for the last time. That is not a bad reading at all, I would say. Now let's switch to the resistance here. It has 100 ohms, 1 kilo ohms, 10 kilo ohms, and 100 kilo ohms. I switch to ohms and let's measure it. 100 ohms. You can see the ranging is actually quite fast and it settles down quickly. Now I'm also measuring my probes. So let's roll them out. Something remarkable for this device is also rel is valid for all ranges. It can auto range while being in rel. Technically, all these math functions you see, you can combine them. It is possible to be in relative, use min-max, combine it with the expand function, and set limits. All together. You just have to find out how to fiddle it. It's a bit complicated in the manual, but it's doable. And this is something you rarely see in today's multimeters unless they have a huge LCD display with a lot of menu. So I find this rather remarkable. Let's continue with 1K ohm. See here, auto ranging quite quick again. It ranges down. Perfect. 10K. Perfect. 100K. Perfect. Quick settling. It toggles a bit in the last digit, but this is due to the value being right in the middle. If I use a high resolution meter, I realized that the value is about in the middle of what it is, and then it starts toggling with the last digit. So it's, I don't know, kind of an additional resolution. Let's go to 1 mega ohm. However, this board is truthful about what the values of these resistors is. I don't know. It's just for toying. See, rather quick. Let's return to 100 ohms. Quick and beautiful. But let's have a look how fast the auto ranging in ohms is. That is something that is very interesting. And for that, as I said, I will just hook up this photoresistor to the meter. So, now you read it. It's basically seeing all of the LED lighting here I have. Let's wave my hand over it. Oh, you can see beautiful bar graph. Incredible. This is really cool. This is something that would be cool if the meter would be sold as brand new these days. But for mid-80s, unbelievable. See? Can you see 25K? 3.8K. 28K. 3.8K. This is really cool when you're doing diagnostics or something. And besides the true RMS AC measurement, this is actually the area where it's lowest. If you want to see a comparison, I mean, some people complained that the 789 here, that it's quite slow in auto-ranging. Yeah, possibly compared to other devices, but oh god damn it, the lighting here. But let's compare it with this photocell, because I found out it's some areas where it's auto-ranging not as fast as like other highest high-end meters, but most of the time I could not really understand what the criticism is, because if you now have a look at it measuring it, so let's put it a little bit out of lighting. So 3.885 something ohms, light source is varying, and now let's move my hand over it. Can you see that? What is slow here? I don't know. I don't understand the criticism. After working with devices for decades, I'm more than happy about this device, and well, it's surely enough for me, but probably other people have other needs. Anyways, so let's switch this thing off to not drain this battery here. As you can see, even the switching is fast. Now back to the 1980s. Let's see how much we've removed from this alkaline battery here. The contact's a bit hard to hit. Oh, more than enough. So the readings of the 584 should not be off by too much. However, even if this thing is genuine. So let's try out what's happening if we measure these beautiful LEDs, because that is something that surprised me, because there are many new multimeters which can not light up most of the LEDs. They cannot measure them. This device was built when this was not yet possibly technically. This was expensive and this was problematic. So let's see what's happening if I measure it. The output voltage, by the way, I documented in the forum as well. You find a lot of pictures from me from this device in the EEVblog Forum. I will put a link in the commentary section. So let's give it a try with the red LED. It lights it up and it measures the voltage drop. No problem with that, no surprise with that. Already a standard part at the time. Let's see here, no problem. Even the bar graph is kind of quick about it, even if it cannot measure it. The yellow LED, no problem as well. It measures the voltage drop, very quick about it. Blinks, no problem. Green LED lights up. Does it come up in the camera? It is lighting up, it's measuring. I don't know, maybe I just took them out of the box basically and soldered them into this board I created. Maybe the LED is shit or I soldered it down. But you can see it can measure it. It lights it up. And the bar graph is even quick about it. And what actually quite surprised me, and I thought maybe this is not really a blue LED, maybe they just painted it. I asked, why? Why on earth? Look at this beautiful blue LED. It has the correct voltage drop. About 2.4 volts or something when I measure it with the BRYMEN. It lights it up. It cannot show the voltage drop. It just goes up like 2.3 volts, so it's slightly above and it can't show it. White LED, no problem either. The bar graph gives it up. Cool. And if you swap the leads, let's just try it out. No faulty reverse readings, obviously, unlike modern devices. And now in the center I have a color changing LED that contains a small IC that is driving an RGB LED, not adding any significant voltage drop to it, but the advantage is it's really individual chips and they are swapping, and you can see how fast it's actually doing the measurement of the voltage drop, which is a nice feature, you see. Now it's combating against the different readings, it even starts blinking, so this is a good performance view on the capability of the bar graph. While the reading is always taking long, the bar graph, no problem, is showing you, oh, something's happening here. Yeah, you might want to see the comparison to the BRYMEN, which performs quite well against this LED as well. Let's hook it up. I should have put it in next to it to start with. What do we need here? This reading. Beautiful. So, LED mode works fine. Let's put it to my colorful LED here. Isn't that cool? How fast it is. Remarkable. See? So it's not just a strangely painted yellow or whatever, I don't know. Remarkable. Good device. Love it. So let's continue on with my doing here. So obviously it can do other measurements of diodes as well. Something like this here. Small PCB from China. Oh, other way around. So let's see, very small voltage drop. It can take a couple of amps. Very nice, correct. And I can measure this high power LED. I just salvaged it from some broken flashlight, but the circuit doing the voltage conversion was blown. It can light it up, as you can see, but it doesn't give me any voltage drop because at the time, I might imagine, high power white LEDs have not been in scope of the developers of this device, probably in sci-fi movies. Then let me show you the thermocouple function. It gives about a good reading. You don't need to shorten the leads out as you need to do otherwise to get the internal temperature reading. It does it somehow automatically. It has some detection for it. But something that is really remarkable for the times, because only very few vendors could do is the continuity. These days, many vendors buy like crap continuity readings, like very slow, you touch the leads and you go get a coffee, and when you come back it starts beeping or something. Not with this device. Can you hear it? It sounds strange, it sounds like the 80s, but it's fast. It's surprisingly fast. And, you know, is it useful fast? That's why I have this broken board. I destroyed it by some negligence a long time ago, and I keep it for like measuring and poking around. It has some nice buttons on it. It's an EEVblog board, and I can use it to just check, okay, where are the grounds on this chip? Some standard task is to just find out where is what is the orientation, and I will slide over it. Ah! Ground here. Ah! Because I don't need a meter to be theoretically faster than my ears can even notice it, I want it to be practically fast, and this is actually practically fast. See? Only if I go over it very fast it starts missing it. Now I touched this pin at the end. Was not a mismanaged measurement. See? That's quick. That's great. That's beautiful. See here, beep, 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 beep. Wonderful. Wonderful. Why do I have this device? When I learned all this stuff, when we have been instructed, we started with analog meters. They really had us start with like analog meters, you know, huge brick things with a needle, and this needle was done for years. It has been tortured by people learning multimeter. This was like bent over. It looked like, oh, awful. And once we figured out our way around these meters, they allowed us to take a look at the real thing, but only if we've proven, okay, we will not like ruin it the moment we start with it. We hook up DMMs range and hook it up to the socket outlet, and smoke comes out, and everyone is crying and running, the building is burning down or something. Once we've proven that, we get something like this, but from NORMA. I don't know which exact model it was, but it was a NORMA device from the same line. And it was like day and night. It was sitting there, and we have even been allowed to use it within certain limits for private projects for as long as we could be trusted to use it in the area of the lab. And that was so beautiful. It was like day and night, you know, you could measure stuff, you could work on stuff, and that is a little bit like why I look at these weird manual ranging meters from China, and I ask myself, we're well into the 21st century, and they're selling manual ranging meters with 2000 counts like it is the innovation of the century. Yes, beautiful case, obviously. Don't drop it, but this is the technology from the 80s. This is the technology of today. 2000 counts manual ranging in cheap plastics. I don't get it. Maybe someone out there has really good use for it, but there are better cheap meters around. Because this thing, if you're lucky, like I searched for a device from NORMA for a long time. I got it in the Siemens brand. It cost 90 euros. This is unbelievable. Originally, I talked to some people in the forums, and they said, yeah, a wild guess, it was like 1,400 marks at the time, which is, I joked around, but some of the instructors made a joke, oh, don't drop this device, it costs about as much as my car, and we all had a good laugh. I don't know, maybe he drove just a very cheap old car, but that was the price of it. It contains an ASIC. It can do these measurements, quick updates. That is a remarkable device, even if you would like to use it today. Of course, there are differences. It lacks the last digit when you do temperature. The true RMS measurement is a bit slow. Frequency measurement doesn't go down as low as you might expect it. Let me show you a little bit about the AC measurement here. I have prepared grid voltage here for you. See, Let's hook it up. See, it takes its time. But it's actually true RMS. I measured it. It's only like 0.6 to 1 volt off. And the reading is not even slow. It's about what the grid gives me in my residential area here at this hour of the day. And to measure the frequency, let me show you that it even does it in the antenna method. See, no problem. Obviously 0.051 kilohertz. Yeah, but if you want to measure the grid, it's okay. You want to know, yeah, grid there, grid not. It's mid-80s. Who on earth had a frequency counter in his multimeter in the mid-80s that can go up to like, what, 150 kilohertz? It's crazy. Cool thing. It is obviously not perfect, but it's remarkable. And why I did the comparison with the Chinese meters. You can of course always buy a good quality meter. It will cost you, not with the BRYMEN obviously, they are unbelievably cheap, I don't know how they do it. But you can do it. Or you buy a 20 euro meter that might last a year, then it becomes imprecise and will blow up, who knows. The manufacturer will not answer to your troubles. If you're happy with it, stay with it. But you can also have a look at what technology from the past that is still not too outdated, that is actually competitive against most of those cheap meters. Look at it, look at what it can do. That is competitive. You can get it quite cheap. Look at the great meters from the 80s. Look at the great meters from the 90s. Rather buy a used device. Of course, there is always the risk. I could have bought this, it could have been dead, display broken, chips rotten away, who knows what. I was lucky that it's only extremely dirty, but fully functional, calibration on. That was lucky because this is hard to calibrate. It is done, the adjustment is done via an EEPROM. Yes, EEPROM, mid-80s, I don't know. Unity did like the small adjustment ports all around the device like 8 years ago. This is doing EEPROM, but maybe I can find someone who could tell me to adjust it. And I could still have a company adjust it. This is what you get when you buy a brand name. Calibration companies in Germany and Austria, they still have it in their list. If I would pay ridiculously a high amount of money, they would adjust it for me down to spec, if necessary. Who would have thought of it? I was surprised when I researched for it. If you have any questions about it, teardown I obviously not do, because the case, you see, it's how cases from the era look like. Spec on the back. I think you can see I need to get into here with the screwdriver. You don't just screw it down. What they did these days, only Fluke did it well as far as I know. The next generation was already like rubber boot and all the good stuff, but this generation was still like plastic box that is clicked in. But you can have a look at the pictures in the EEVblog Forum. I will post a link if you're interested how it looks in the inside. It's rather more fun to look at the standstill pictures than to look at me poking around in it. If you want me to take some specific measurement about it, just let me know. Otherwise, I don't want to talk too badly about Chinese meters, but I had bad experiences with them in the past. I found out that sometimes you're lucky, sometimes you're not, and it is not what I want with equipment that I hook up to very high voltage. And this is another argument for quality meter, even like this 30 years ago. You can see it doesn't give me a CAD rating here, it doesn't give me a CAD rating here, because formalized CAD ratings are a very new concept, but it gives me values based on the standard that these CAD ratings are derived from. Have a look here. It tells me 1000 volts, category 1, pollution degree 1, 630 volts, category 2, pollution degree 2, 300 volts, category 3, 150 volts, category 4. It's from an yet outdated version of the standard that had been internationalized, and now we know it all as the CAD ratings. They give it for every single individual function. It has not the same kind of rating for all the inputs and all the functions, because maybe they have not been able to do it like that, or it was too complicated or unnecessary or not yet invented, that you put like a whole meter under CAD 4 and it has to confirm to that in like every individual functions like the Fluke does it meanwhile. Like here in the current range, it only goes up to 380 volts, but as far as I could see in the inside, this is only because of the fuse rating and not because of the circuit protection. But I'm not very much an expert about this. See? The detail grade in this manual, unbelievable. And it's like typewriter font. I want something like this from today. I miss it. I could repair it if I would be able and not ruin it entirely, of course. But this is theoretically repairable by someone competent. You can look at it. Obviously, it would be a problem to get these chips, the NORMA MCC1 and MCC2. They were custom chips, and you cannot just like walk up to Conrad and say, please give me a part, and he will just take it out of the box. That's out of the question. But if some input protection is blown, no problem to fix it. It's this. It has some SMD parts like the IC, which is also, I found it interesting for a device from the 80s. Rare, but most of the parts are even THT parts. No problem. I was surprised, so I wanted to give a video about it to show that there was something else, that it is not all innovation. If you have a battery run time. Meanwhile, they are selling devices with lithium-ion battery lasting like 8 hours. This thing gives you, if you add a lithium battery, 9-volt transistor battery, it lasts like 1,000 hours or something. I don't know. I found inside a 9-volt battery from the 90s. It was like barely alive, but was able to switch on the device and take measurements. This is a different class of device. I was just surprised. If you have any questions about it, let me know. Sorry for talking my head off about it, but I'm still amazed about it. And I'm very happy that in the forum link you can see that other peoples have the same kind of meter. They have been able to get it, and one guy was even very, very lucky to get something that looks to me like a rarity from ENERDIS. It looks like NORMA tried to get the market, and they entered to the French market, tried to create a stand there. But as far as I could research, there's nothing to be found about these meters under the ENERDIS brand. So probably he has like 1 or 2 of these have been made. I don't know. So if you're a collector, go get it. You might be lucky as I was and get one very cheap. I will not just have this standing around and catching dust. I will use it on my bench for hobby projects, and I'm quite happy about it. So have a good time, measure with whatever you like, but be careful about what you trust. I trust something like this, and the Chinese parts are for fun. But not this kind of a fun, but they're ugly fun. Have a nice day and a nice weekend. Bye.